Now we have our next speaker, Jaap Zuiderveld, and I would already like to invite you to our stage here. Yeah. We have another. Yeah, we will give it another try. Maybe now it works. Yeah. And yeah, let's go. Pardon.
So first of all, thank you, Ragnar. By the way, if you're looking for a job, join us, please. I love the way you promote us, by the way, in a certain way, because everything you talk about is what we believe is happening in the world. Yeah, and for sure, because I said it today, I think, you know, we need to start working on it, not talk about it, but working on it. And I think, in my view, we're talking too much about it, but doing it, that's what needs to happen. But anyway, I would like to start with a small video about NVIDIA, because a lot of people know us, but don't really know us. So I really want to start with a small video. Let's see if this is going to work, guys, because the previous presentations, it didn't work. So I'm going to click.
Ready?
Yes.
Once upon a time, it was all fun and games. NVIDIA started off by making chips for video game machines. Graphics became serious business when people started using NVIDIA for blockbuster movies, medical imaging devices, and the world's most powerful supercomputers. And then one day, researchers discovered that our technology was perfect for AI. Today, NVIDIA is the engine of AI. Engineering the most advanced chips and systems, and the software that makes them sing. So robots can lend us a hand. Cars can drive themselves. And even the Earth can have a digital twin. We live to tackle the world's biggest challenges. And don't worry, we still love our fun and games.
Ready, go!
Sorry.
Upon a time.
Oop. How do I go to the next one? Can you click to the next one, please?
Go!
Can you help me? Oh, sorry. The other one. So, yes, NVIDIA. Most of us know NVIDIA from gaming. Yeah. Now, I want to start with that also. I'm not here, don't worry, I'm not going to talk about gaming also, but I just want to make sure that we understand it. Gaming is probably one of the most challenging computational tasks there is in the world. A lot of stuff you do today with AI comes from gaming, I can tell you. It's not only what we do as NVIDIA, but it's also what's happening in the market. Yeah? Now, I'm not going to talk about speeds or feeds today. What I'm going to talk about, where are we today? Where is NVIDIA today? And how much do you really know about us? So, in essence, we're a software company. We're not a hardware company. We have 24,000 people today. 22,000 people work in engineering. 22,000 people. We are an engineer-led company. We're not a sales company. We're led by engineering. Out of those 22,000 people, 70% do software engineering and 30% do hardware engineering. Nobody really knows this, but this is so important. And that's why I'm starting with this slide, because that's where we are today. This is the full stack of NVIDIA, the full stack. But I'm going to start at the top. If I look at Modulus, Modulus is a physics-based simulation. So what we did, let me just explain what we did. We pre-trained models, yeah? We pre-trained models to make it easier for you to work with our technology. And our technology should be available to everybody. That's how we look at it. We call it democratize our technology. Yeah? We have pre-trained models and SDKs to make it easier for you. So if I look at Modulus, for example, it's a pre-trained physics-based model. And just as an example, Siemens Energy uses it to develop wind turbines, sorry. That's my Dutch, confused with Portuguese and everything else. Wind turbines. Clara Monai, yeah? That's a healthcare pre-trained model. This is a model which we developed together with Guy St Thomas Hospital and NHS in the UK, which is an open source model to understand image recognition, yeah? And we used federated learning. Very important, something we can use, for example, in finance also. It's all about protecting your data. As you know, healthcare data is super important. A pre-trained model, which you can already use, Riva. Yeah, Riva. Riva is a, I call it natural or language processing model. A good example is Amex. Amex uses it. I always like to use examples. Inside their people who take the phone use that model, so when somebody calls, they can recognize a voice, or they can recognize the question, and they can answer their customers much better. Yeah? Maxine. Everybody uses Maxine here today, probably. Everybody uses, why? I will tell you why. Maxine is about enhancing your video images. If you use Teams, if you use Zoom, you use Maxine. It's about enhancing your video, making it nicer, taking the background away. You can put a picture, you know if you use Teams or Zoom, what you can do. That is Maxine. Nemo. Very important, NLP, natural language processing. But this is really advanced. This is where, as a good example, we use Alexa, where you say something, you speak, and it answers you. It understands what you ask and how you answer. A pre-trained model. Yeah, a very important one, Merlin. Merlin is a recommendation engine. Super important. I really don't understand that. If I look at the markets here, in the German market, there's not asked a lot about it, but these are pre-trained models where you can compete against the guys like Amazon, for example. You don't need to train a whole model. You can already take that model and train the bit yourself, but you can take it and learn how to do a recommendation engine. So important. Avatar, you have seen it here, we use it here, but Avatar is creating your own avatar. I've seen in a presentation before is where you want to be more human, where you create a human which speaks to a human. I know we are working with different companies around the world on creating an avatar, even within the finance industry, for example, but in every industry, people are interested in it. Drive. Drive is very close to this home market, Germany. It's not home market, but it's to the German market. Daimler is the best example. Probably a lot of you know that we have a partnership with Daimler. We develop the software which they're going to use for their self-driving cars, which they're going to put on a road in 2024. They use Drive. Isaac. Isaac is all around. Sometimes I need to think myself. I need to help a little bit. It's all about robotics. Different examples. Amazon, I always like to use an example. Understanding how you can mitigate the huge centers they have. Amazon, as all of you know, have huge, how do you say that? Sorry, I forgot the word. Retail centers, but sorry, I lose it. But it's understanding the automation of their distribution centers. Sorry, I have it again. The distribution centers. Understand what the best routes is. But one of the biggest things Amazon had, they had a lot of accidents in the distribution centers. How to mitigate that. And the automation they had in the centers is very low, so they were looking with them how to work on that one. Metropolis. Metropolis is all around video surveillance. That's the most important one. Most of the airports today use Metropolis. Most of the airports today scan already when you come in, when you come from a plane. They already know before you go out, especially if you go to countries like Dubai or Saudi, most of the airports use our technology, and they already know exactly when you come in, who you are, what's happening, what's doing, because they already have scanned you. And last, Holoscan. Holoscan also very important. It's used in medical imaging, and it's used for medical instruments. Siemens is a great example. Siemens is a huge user of Holoscan. It's all about understanding, how you develop models which are better. Pre-trained models which everybody can use. Yeah? It's very important to understand that. Now, I'm putting the full scale here. This is, here we start with what we started with, the GPU, CPU. We're coming with a CPU also, the DPU. All that is to accelerate your workloads in a data center, understanding how a data center works, how your applications work. One of the things we do is understanding how to approach a market also. So we work by industries, industry verticals, understanding an industry vertical, taking people from the industry vertical on board who work for finance, who worked for finance previously, or who worked in healthcare previously, and help us understanding those verticals better and working very closely with those customers. And Ragnar said it very rightfully, how we approach it, very fast. We develop, our route to market is probably 5 times faster than anybody else, because we work together with the customers to develop a product. The product is not even finished. I know people who join us always say, Jaap, the product is not finished. I said, so, what's the problem? We're going to finish it with the customer, because then we have the input from the customer and we know what's happening. I know it's a Silicon Valley-based way of approaching a market, but it works, I can tell you. Now, to give all this a little bit more, I'm not sure if I'm going to do the right one. No, I went too fast. I need to go one back. No, I'm right, sorry. Now, put this a little bit in perspective. So, what's really happening? Yeah? Now, in fact, if you look at what's happening to the acceleration or the speed of where we're able to, let's say, go for compute tasks is increasing enormously. If you buy today an HPE server with a Hopper, with Hopper architecture, which will come out soon, yeah, with one GPU, that's already faster than the fastest supercomputer worldwide 10 years ago. That's one server. It's faster than the supercomputer 10 years ago. Yeah, that tells. Today, we have 3 million developers worldwide working with us. Now, the 3 million is one, but do you know that more than half of them joined us in the last year? Yeah? More than half of them joined the last year. That is important to understand. Now this will, we are following 10,000 startups worldwide. By the way, 450, we need to synchronize a little bit. 450 in Germany. 450 in Germany. Those are people who only work with our technology because, sorry, that's what we do. But it tells a little bit about what's happening. And I can echo Ragnar. The majority of our starters are in Israel. Now, Israel is also one of our home markets, as we bought Mellanox 2 years ago. when the deal was endly closed. We have about 3,000 people in Israel, and the startup community there is thriving, seriously. But you learn so much from the startup community, and we work so closely with them together. Today, we accelerate more than 2,700 applications. This is really important. These are applications which are, applications which are put on the market by ISVs, independent software vendors. Now, you can say to me, yeah, what does that really mean, speed up or accelerate? Why do I really care? Because it's working now. Well, I will tell you why it's so important. There are many examples, but if you want to have an outcome, so a lot of tasks today, because the data is becoming quite, let's say, bulky, and if you want to work on a model, sometimes you need to wait a day before you know the outcome of a model, or before you know an outcome. If you have the answer within 5 minutes, it changes your business perspective completely. You make decisions in a complete different way. You're much more agile, you're quicker, you're faster. It's not replacing, but you're able to make a decision quicker. That's why acceleration is so important. And you're able to do much more work also. This is always interesting. The most expensive good you have is your people. The most expensive good you have in a company is probably the people who are doing data mining. They're the most expensive ones because they are rare. Yeah? And you give them a system which they need to wait. So they go for a coffee, they wait. You know what the cost is of a data scientist, a really good one? At least $500,000, at least, a total cost. Then you're at very cheap, but it goes up. If you have a lot of them and they're waiting before they can do anything, it doesn't matter. The cost of hardware is just, it doesn't matter. So it's really important to understand that. Today we have more than 450 SDKs and models we support. And we have more than 8 million CUDA developers. This is really important. This is our parallel programming language, which is used on a GPU. And I think, going to the next slide, how do I capture this a little bit? For me, AI occurs everywhere. That's what I said in the beginning. Yeah? For us as NVIDIA, we have a growth of 50% to 60% year over year. Yes, also in Europe. I have people asking me, also in Europe, because it's easier, because the number is lower, so it's easier. But I can tell you, it's also happening in China, it's also happening globally. It doesn't matter. Yeah? By the way, a huge opportunity. Yeah? Here I went through the numbers. We have today 25,000 customers, 20 globally, working with our technology. We have more than 1,300 partners understanding our technology. And here I mentioned some of the industry leaders which rely on us. European. There are a couple I always like. IKEA is a very good example. They are a big fan of Omniverse. Yeah? Daimler, everybody knows. BMW, Omniverse, I'm going to show that a little bit. Siemens uses it in many aspects. Red Bull, the reason that my fellow countryman Max Verstappen is able to win is because we helped them designing a better car. We're a little bit involved. It's interesting, but these are things, and I can go on and on and on and on. If I only look at Germany, there are so many initiatives happening. I mean, I know that because I'm talking to Applied AI, I'm talking to DFKI. What these guys are doing is just, but they need more money. They need more hardware to do the work. And there's so many opportunities. It's just immense, I can tell you. I mean, this one is interesting also, AstraZeneca. You know that AstraZeneca, we built a supercomputer in Cambridge, and they used that supercomputer to develop the vaccine for COVID. They accelerated by more than a year to enable them to produce a vaccine which came much faster to the market. All things which are really relevant. I mean, for me, what I always like is the Human Brain Project, which we're doing in Jülich, to understand how to cure Parkinson. They use our technology also in Jülich, but very important, how a disease starts, because then you can cure a disease. Things which are all really important. Now, for me, the next wave will be, I call it understanding the 3D world as is today in a virtual environment. Yeah? What will happen is, if we look at architecture, if I look at design, everything else is how do you simulate a physical-based real model in a virtual environment? So important. That will save so much money. That's going to be the next thing. That's going to drive the next thing. It's going to be very important for media entertainment. Today, more than 8.6 billion of compute hours is used for rendering in media entertainment. It's immense. These are all things we don't really know about, but it's so immense. And doing realistic-based rendering is something we're able to do. Product design, manufacturing, robotics, autonomous vehicles, all these guys work in virtualized environments to understand their products better, to save money while they develop their products. And I can tell you there are many examples who are already using this technology. This will certainly be the next wave. Now, I'm going to use one example. I need to look a little bit at time, sorry. This is BMW. BMW is a very well-known example. I think we talk about it, but they built a complete digital twin, and where they simulated how to build a factory, or how to set up a factory effectively, yeah, how to plan it, how to get all the people worldwide together in a virtual environment. It's just what happened there is quite unique. I know I will show the video a little bit. It doesn't really speak, but when you really understand what it means, there's a lot behind it. There's a lot when it comes down to logistics, how to improve logistics, how to improve costs, where it went wrong. They could all understand it without the people being there in a digital environment. I'm going to use this video.
BMW has continued building on the momentum of their Factory of the Future initiative we showed you earlier this year.
This is all digital,
On average, they produce one new vehicle every minute, expanding the initiative to now include digital twin projects at 3 additional factories, which total more than 6 million square meters. Meeting BMW's demands for continuous improvement and innovation requires simulation of complex production scenarios to speed output, increase agility, and optimize efficiency everywhere. NVIDIA Omniverse introduces new simulation capabilities everywhere BMW needs to make critical decisions and introduce automation. BMW and their partners have also been connecting new users and tools to expand the Omniverse ecosystem. Spanning every aspect of the BMW Factory of the Future, Omniverse allows BMW to collaborate and simulate from the entire plant level down to comprehensive engineering detail.
It's quite special, I can tell you. Sorry, I'm going to make the mistake again. I thought of clicking to the next slide. Can you click to the next slide? So, for me, I just want to close down on a couple of words. We close very close partner with also with HPE. Yeah. Now, how I approach always this is we're there to help HPE and to help you. Any questions? Let us know. Talk to us if you don't understand it, because it's complex what we do. AI is complex. It's not easy, I can tell you. I'm now working 8 years in this business. I was there right from the beginning when we started. It is complex, but there is a lot of things you can do. The breadth of technology we have on board is enormous. I'm more than willing to share with you for you to understand how to work with us together with HPE. More than welcome. I'm going to close with a small video around AI. I always like that. Sorry, it's or I can just stop. I can just stop and leave it. That's maybe better. I'm not going to close because I'm over time already. I just had a small video around, AI, but let's leave it. It's fine. Thank you very much for your time. I could spend much more time here, but thank you very much.
Okay. Yeah, thank you. I think we could watch also some others. You have so much with
Correct.
you. Really, really cool. So I know you are a Dutch living in London.
Yes.
But you also want to take care of Germany,
Yes.
as Ragnar also like to do that.
Yes.
And I would like to know, how do you do that? How do you represent NVIDIA in Germany?
Yeah, so we have a, so I'm always from principle working with local teams. I have a local team here of, well, we have in fact almost 1,000 people in Germany.
Yeah, okay.
But that's a lot of software engineering in Munich and in Berlin, by the way, because in Berlin is our headquarters, by the way, on development on Omniverse. Yeah?
Oh, good.
So there's a lot of knowledge in this country available, but I have a commercial team of about 20 people who all live here and talk to you. There are a lot of people here in the room now from my team. You can put up your hands if you see. So
I see 3 hands.
yeah,
4?
correct, a lot. That's a lot compared to the rest.
Already,
yeah.
just to let the online audience know.
Just come to us. No, I work from the principle with a local team, and we support the local team. But I'm really interested in what's happening in Germany for many reasons. I believe the automotive market still is a huge market which will go through a huge change.
Yes.
So that's very interesting how to follow that. And for the rest, I think Germany has a huge potential, but they need to get on it. If not, the same thing will happen. What happened in the auto industry with electrification, they a little bit kind of were too late. Yes. And here they need to jump on it. That's my personal view. So yeah.
Yeah. I would like to discuss some more questions, but we are already out of time. So thank you so much for your presentation, and see you later.
Thank you.
Thank you.